In this problem, we want to ultimately determine whether there's a relationship between whether music is playing in a store and whether there's high sales or not. So a store manager thinks that playing music in the store will increase her overall sales. She conducted an experiment for a period of time and found the following results. This right here is a table representing the results. This is called a contingency table. You will see contingency tables in multiple sections in the future. So let's make sure that everybody can first read them. So this 32, notice it doesn't have a uni here. Let's pretend like this is 32 hours. So basically, you have to look at the column that the number is in and the row that it is in. This means that for 32 hours, there were high sales while music was playing. So for example, this 18 means for 18 hours, there were low sales while no music was playing. And then of course, you've got totals as well. 46 here means the total number of hours that they had high sales is 46. There were 42 total hours for which there were low sales. There were 56 total hours for which music was playing. And there were 32 total hours for which no music was playing in the study. And then this 88 is the sum of each of these. So the survey was done for a total of 88 hours. Let's now actually go through, and ultimately we want to answer this question right here. Are the two events, music playing and high sales, independent? Explain clearly by referencing two specific probabilities above and using one of the phrases less likely, equally likely, or more likely. To do this, there's a couple of probability questions before that I want to answer, and then see if we can figure out which two of these three probabilities we should reference when trying to answer part D. So what's the probability there were high sales in the store? Well, there were 46 total hours for which there were high sales out of the total of 88 hours for which they were conducting the experiment. So we got 46 88ths. And because we're going to compare them, I prefer to convert this to a percentage. And this is approximately 52%. For part B, what's the probability that music was playing? Well, music was playing for 56 hours out of the total of 88 hours. So you have 56 88ths, which is approximately 64%. Now, what's the probability there was high sales given there was music playing? Anytime you have a restriction such as given that there was music playing, this is now a conditional probability. The first two problems, part A and part B, were not conditional probabilities. This one is. Ultimately, you're restricting your world to the given part. So the given part is that music was playing. So what I suggest you do is go to the contingency table and circle the row or column that the music playing is in. So music playing is this row. I'm going to circle that entire row. And now I'm going to restrict my world to just that. I can essentially completely ignore everything else that's around here. We're only looking at that first row. Now, from there, in that world, we then want to see what's the probability there were high sales. Well, there were 32 hours out of the total of 56 hours. So we have 32/56, which as a percentage is approximately 57%. Before we discuss part D, I want to make note of something here. Notice that the conditional probability had a different denominator than the two non-conditional probabilities were. Whenever you're doing these contingency table problems, that will occur. So your basic probabilities, these two, are out of the total amount of time that that the survey was conducted. But the conditional probability was out of a different number, in this case, out of the 56 total hours for which the music was playing. Now, let's answer the question, are the two events, music playing and high sales, independent? We need to compare two of these, and we cannot randomly choose two of them. It's specifically two that we need based off the definition of independence. So if you can recall from the previous screen, the probability of A given B, that needs to be compared to the probability of A, not to the probability of B. And we want to know, are those two things equal or are they not equal? Are they different? Again, the kind of important thing here to see is that whatever this event is up here, that's the same thing that the basic probability should have. So Let's perhaps make notation for each of these problems. So this 52% was the probability of high sales. Let me call that P of H for high sales. And this 64% was the probability of music playing. So let's call that P of M, for which is the probability that music was playing. So then with M and H defined like that, what's the probability there was high sales given that there was music playing? Is that the probability of M given H or the probability of H given M? It's the probability of H given music playing M. So it's specifically the probability of H given M. So now looking at the definition up here, we need to compare this conditional probability. Notice there's always one conditional probability in the definition. We need to compare this probability, H given M, to the probability of H occurring. Notice whatever that is there has to be the same thing here. So we're going to compare those two percentages. We're going to compare the 57% to the 52%. And of course, 57% is not equal to 52%. So probability of H given M is not equal to the probability of H, since 57% is not equal to 50%, or 52, sorry. This means they are dependent. So these are dependent events, and now we can write down an explanation that's a bit more specific. We can explain clearly by referencing two specific probabilities above and using one of the phrases less likely, equally likely, or more likely. So technically, the probability of H given M was 5% higher. So that one's the greater one. So we can simply say the likelihood of having high sales given music is playing that's the probability of the H given M, is greater than the probability of just H. So the likelihood of having high sale given music is playing is greater than probability of high sales. So not only are they dependent, we also know that the likelihood of having high sales given music is playing is greater than the probability of having high sales in general.